But first of all, we're going to talk about surface forecast, surface features. So one of the questions I received was, what is a cold front, a warm front, and an occluded front? And specifically, the question I get asked a lot is, what is a surface pressure trough? Also, we're going to talk about what does it mean when there's an area of low pressure or high pressure represented on these charts? Also, what does it mean when the contours or isobars are close together or spread apart? Well, first of all, let's take and do a kind of an overview of some of the features you're going to see on these various charts, whether it's a surface analysis chart depicting conditions that happened in the recent past, or a surface forecast chart, such as a prog chart. So we're going to discuss the reasons we have these features presented on these two different charts. Well, first of all, let's look at frontal systems and frontal boundaries. Basically, anytime you see a front representing on these charts, that basically indicates that there are multiple air masses, and where those two air masses touch, that's essentially where you're going to see the frontal system. And so an air mass is one that has a consistent temperature and moisture profile across the line of latitude. So if you pick a line of latitude here and look at the general profile of the temperature and moisture, tends to be pretty much the same within that air mass. So we might have a cold and dry air mass to the north and a warm and moist air mass to the south. And where they meet in between, where they butt up against each other, that's where you'll find the frontal system. So why are there air masses in the first place? What is an air mass? Well, the easy answer is Mother Nature abhors extremes. So we know that there's cold air up near the poles and warm air near the tropics. And as a result of that, this kind of differential heating throughout our globe creates an imbalance that Mother Nature doesn't like. So it's all about this differential heating that occurs, and then Mother Nature attempts to bring that back to a balance. So to reduce or eliminate that imbalance that's out there due to the unequal heating of the Earth, she'll bring down cold air from the poles and move warm air up from the tropics. Sort of like a weather shell game that she's playing in order to bring things back to that equilibrium. And so this differential heating that we see creates what meteorologists call, very fancy term, but it's called baroclinic instability. And if you look aloft up in the atmosphere, all of the shell game is not just played at the surface, but it's also played at higher altitudes aloft. So if we have in this case, let's say our jet stream moving through west to east across the country, what you're going to notice is that these areas where you see a trough or a dip in the jet stream, that's cold air being brought down from the poles. The opposite is true where you see a ridge, that is warm air being brought up from the tropics. And it's this kind of mechanism that creates our major weather systems that we see on prog charts and surface analysis charts. And of course, where those two air masses collide and come together, that's what we see as a frontal boundary. And if you were to look at how the wind essentially maps to those frontal boundaries, you'll notice that where there's a front, there's an area of convergence. So you're bringing the cooler, dry air, perhaps, down on the western or northwestern end of that front, and then the warm, moist air up from the Gulf of Mexico. And where they meet here is that area of convergence. And so if you have weather that's, air that's converging at the surface, has nowhere to go but up. And so frontal boundaries are basically places where we see air converging. So when you see a cold front on these charts, that means the cold air mass is on the move. And of course, when you see a warm front, that means the warm air mass is actually on the move. And we know that in reality, all these air masses are kind of moving together, but essentially the cold front defines where the cold air is moving into the warm air. And then a warm front defines where that warm air is moving up into the cold air. A stationary front is simply just that. Air masses are not moving, they're stagnant. And the one that's the most difficult one to explain to pilots is an occluded front. And essentially, an occluded front, it simply implies that one air mass is willfully taking over the other. And there are two types of occlusions. There's a cold air and warm air occlusion. Not to really have to worry about that a whole lot, but essentially when you see an occluded front on a chart, you know that that particular weather system is reaching its maturity. So typically we see a weather system go through this occlusion process, no different than when we see a wave in the distance that's ready to eventually crash onto the beach. As the wave is further out and eventually gets to a point where it curls and crashes onto the beach, think of that as kind of the occluded front. Essentially, it's reaching its maximum or it's reaching its maturity at that point and eventually will dissipate. So it's kind of the first point where the weather system reaches its maturity and then trends towards dissipation. So the movement of these air masses is generally controlled by these pressure systems that we have, highs and lows. So a low pressure typically develops on this pressure trough between air masses. So when you have an air mass butting up against another, essentially it creates a pressure trough, just like you would dig a trough in the backyard to bury a pipe. Same kind of principle. And essentially, if you were to pour water on each side of that trough that you dug in your backyard, the water would essentially sink to the lowest point in that trough and then eventually converge and move upwards. So as that happens, you can only imagine that there's going to be some swirls in that area where the water is flowing down into that trough. Same thing happens in the air. As that air converges together between those two air masses, in some cases, we can get that air to move and then finally develop into a circulation, and that's the area of low pressure. And so we get pressure systems because of that hemispheric imbalance I just talked about, mainly driven by temperature. So we know that temperature differences across the front drive pressure. Temperature differences drive pressure differences that ultimately drive the wind. And we know that air always moves from high to low. And that creates the circulation that we see in the form of areas of low pressure and high pressure. Now, the question I get a lot is, should I care about a frontal system? Well, some fronts actually have a lot of severe weather associated with it, have a lot of clouds, potentially low visibility, lowered ceilings, strong and gusty winds, possible severe turbulence, icing, all that may be in and around these areas of frontal systems out there. But in some cases, some fronts can actually be cloud-free, can contain unlimited visibility and be actually quite benign. I see this a lot along the eastern US. I live in the Charlotte area. And it's not often, but sometimes we can get a frontal system come through. And the only big thing that you notice is really that it got actually, hot, hazy, hot, and humid before that front went through, to still being pretty warm, but being very dry on the other side of it, because a frontal system, like a cold front, is not only a temperature difference, but it's also a moisture difference across that boundary. And so one day it can be really hot and humid, and the next day be warm and pretty dry and tolerable. And so really it depends on the front, how much moisture it has to work with, and all the other aspects of that, what's happening with that weather system that will drive whether it's a pretty significant system that has a lot of issues with it or one that has very few. So the area of low pressure that develops actually can be quite intense and produce significant adverse weather. Anytime you see an area of low pressure with a lot of concentric isobars around it, that means essentially that this is a pretty significant area of low pressure and therefore likely has a fair amount of weather associated with it. When it gets to be this strong, you can't help but most of the time have to deal with some significant low ceilings, visibility issues, certainly the possibility of convection or thunderstorms, and the possibility of turbulence in and around this particular low pressure system. And especially as you can see, this particular area of low pressure is actually going through the occlusion process here. And I know it's maybe a little bit difficult for you to see, but it's actually a dashed occluded front, which means it's actually in the process of dissipating. So this particular weather system has actually kind of reached its maximum in terms of its maturity and is trending towards dissipation. So anytime you see isobars that are generally packed pretty close together, that means you have a very high pressure gradient. It means the pressure changes rapidly over a given set of distance. And usually, but not always, you'll get really strong surface winds when you see that happen. So in many cases, in most situations, when those isobars are packed close together, what you're going to end up seeing typically is not only strong prevailing winds, but also some wind gusts that tend to be part of this. But there are exceptions to that. When you're looking at a high pressure, on the other hand, usually that's associated with fair weather. But in some cases, high pressure actually essentially provides a situation where there's subsidence or sinking air. And if there's kind of the situation where you have clear skies and calm winds in the overnight hours, that can actually be conducive for ground fog, radiation fog that's occurring as a result of that. So while high pressures are generally associated with fair weather, they can also be associated with some pretty intense radiation fog, some of the most thick fog that you'll ever experience. So just because there's a big old H there in the forecast doesn't necessarily mean that you're going to be dealing with in this case, because you can see all these station models here, which we'll talk about in a bit, all are all filled in, which means you've got overcast skies, and essentially you're dealing with the possibility of low ceilings, low visibility, and the possibility of fog in those regions. So in the case where you see some of these isobars pretty far apart, you can see here that there's one isobar around the high, but it's really far apart from everywhere else. Usually you're dealing, for the most part, with pretty calm winds. You can see in this particular case, there's a circle with a circle around it. That means that the winds are calm there. Or you'll see a wind barb with a little half or a 5-knot wind barb in that particular case. So we're talking about, again, very light and variable winds. But there are cases where you can see weak pressure gradient and still have pretty strong gusty winds. So and we'll get to an example of that in just a bit. So all of this is fine, and certainly I'd like to be able to have every pilot understand all these kind of details and learn how to put them all together, but it's still a good idea to take and look at the prog chart and look at the weather type that's depicted here. You see that here on the left, and look at that in relationship to what you see listed here for the areas of low pressure, the high pressure, as well as essentially all the frontal systems. This kind of tells the story. The precipitation type that's shown here on the prog charts tell you the story of kind of what to expect. You'll also want to look at the convective outlooks. You want to look at other forecasts, such as the terminal forecast. You want to look at all the icing and turbulence charts. So you really have to put the big picture together, not necessarily just looking at highs and lows. But again, look at that as well. Look at the weather type as well as all this other information to get a better understanding of what this particular front's going to do and whether or not you're going to have your lesson the very next day.